Hello all and welcome to this webinar. My name is Ólafur. I'm the product manager for the Treble web application and I will be your host for today. On the agenda today we have three topics. First of all, I will give a short overview of the latest and upcoming features coming to Treble. After that's concluded, my colleague Alessia Milo will take over and give a deep dive into one of these features in particular, that being rendered graphics in the Auralizer. And to conclude, we will have a presentation by Acentech, more specifically Jonas Sachs and Khalila Zaman, who will present two case studies where they used Treble for consulting tasks. So the first update that I want to highlight is releasing today, and this is the ability to upload what we call a visual model into the Auralizer. So this can either be a rendered model or a LiDAR scan that can be exported to the GLB file format and then uploaded to the Auralizer to serve as a visual overlay on top of the acoustical model. This will allow you to create much more dynamic and visually interesting scenes in the Auralizer to present to clients. And this will work both in the Auralizer itself and shared Auralizations, which you can share with external parties that don't need to have Treble access. Alessia will give a deep dive into this specific feature, a tutorial of sorts, so I will leave it at that. But we are very excited about this new and upcoming feature and hope you will take full advantage of it. Another feature that is releasing today is the ability to share Auralizations with your own uploaded WAV files. So one of our most used features is the aforementioned ability to share Auralizations with clients. And up until now, it has been limited by the fact that to be able to share an Auralization, you have had to use a sound file in a predefined sound library. That is no longer a limitation. You can now upload and share Auralizations with your own WAV files. And additionally, you can create your own database of WAV files within Treble, either for yourself or shared with your whole organization, and therefore maintain a scene database, so to speak, of sounds. The latest of these updates that are specifically meant for the Auralizer is an update that will not be out today, but will be released in the next few weeks. And that retains to the robustness of shared Auralizations. So what do I mean by that? So in Treble, all of the computations take place on the cloud, with the exception of the Auralizer, which is run locally. And this is to reduce input lag and create more quality Auralizations. The downside of that is that when you create an Auralization on your computer, that works well, and then you share it with a client, if they have shall we say, a limited machine or a computer, then the Auralization might not work as well for them. So with this update, we aim to tackle that problem by doing the actual calculations and convolutions on the cloud when an Auralization is shared, meaning that when you create an Auralization and share it, you can be sure that it will work for the external party as well. Additionally, this can be helpful for your own purposes when you're setting up an Auralization. When you start noticing some artifacts in the Auralization, you can actually share it with yourself to hear how it will sound without artifacts, since the process will be more robust. More details will come on this when the feature will be released, and we're aiming for just within the next few weeks. So next week, we will also be releasing the ability to simulate lateral energy parameters, both late and early lateral energy, according to the ISO 3382 standard. As I mentioned, this will release next week. This will only work for simulations run after the update. So if you have old simulations and you want to analyze the lateral energy, you will just need to rerun them. And note that this will only work for point receivers, not surface receivers. And this is because of how we calculate these parameters. That's based on the second order ambisonic impulse response, and that is only computed for point receivers. To conclude my part, I want to give you a short overview of other features that have recently been implemented and some features that are planned for this year, later this year. In terms of what we have released, I want to specifically mention the ability to upload IFC files, which is kind of our Revit connection, which has been well received. Back in June, we released a major robustness increase, which kind of increased the quality of the outputted model after uploading the IFC file into Treble. And then in August, we released a speed increase for the calculation process, which was especially apparent in IFC models with a lot of furniture in it. So if you have not used the IFC uploading feature for a while, we encourage you to take a look and see if your results might have changed in the meantime. We have been very happy with the reception these updates have gotten so far, and can confidently say that the process is quite smooth now. But we are also working on further updates to the feature. Two, in fact, are being worked on actively. The first one is a dedicated Revit plugin, so that you can take your Revit model directly to Treble without the need to export it to IFC in the interim. And then we are also working on another kind of improvement to the whole process, namely the fact that when you upload an IFC to Treble, you are able to then take the model from Treble and fetch it into SketchUp if you want to do some additional changes. When the model is fetched into Treble, it is created out of many triangles, and we have identified a path to reduce the number of triangles each surface is made out of. And this will make it easier to do edits to the model in SketchUp after having kind of gone through the process of uploading the IFC and fetching it back, making it easier to do edits. Then another thing that we are currently working on is relates to the geometrical algorithm. So last year, around this time last year, we released an update which we can confidently say made it the fastest geometrical algorithm available on the market. But we have also identified some ways to make it even faster and more robust, and that will be released in the coming weeks with more details on that when that is around the corner. And to conclude, I can name also another thing we're working on, which is a more robust process to create sources and receivers in bulk. So if you're working with many sources in a model or many receivers, we want to make it easier to create a batch of sources at once, grouping them, editing the group, so mass edits, mass creation, things like that. Then there are, of course, many other features that we are working on. We have a pretty clear or very clear internal roadmap for next year with more details coming soon. But for now, I will leave it at that. I hope you are excited by the upcoming updates, and I will give the ball over to my colleague, Alessia.
Hi, thank you for joining our webinar today. Today I will show you the new features to import compelling models into the Auralizer. My name is Alessia, and we will start from the model of a classroom that is one of our demo models that you can find in the web app. If we look at this model, it is a model optimized for acoustic simulations. The features are not very interesting visually, but you cannot currently visualize the textures that you can still attach to this model, even if it's simple. So right now, the first step that I'm going to show you is how to modify the textures of this model and export the model with different textures. So if we click on one of these simple surfaces, for example, the table, we notice that there are two faces with two textures. If we paint one of them with a material from the database, we notice immediately that only one of the two is painted. So if we want to paint both of the faces with the material, we have to do something like reverse faces and paint the other face. A fast way to paint all the faces with the same material in the model is to select all with same material, and then paint. But even in this case, we notice that not all the faces will be painted. So we have to do again reverse faces and then paint again with the material. And we can see from the entity info dialog that all of the faces are now painted with the material we want. Another way to make the model look better is to replace the simple faces with a more interesting geometry. So we could design another chair, or we can use the functionalities of the 3D warehouse and import a predefined component. If we want to import a component, it would be better to replace all the existing components with the definition chair in the model. So I'm going to show you how to do that. You can select all the faces in the chair that are connected with 3 clicks, and then we can use a layer for this, for example, one I made called chair component. And if we move these existing faces to the chair component tag, we will make sure that they're not mixing up. And we can click on the right button and make component on the same layer. So we call this chair component. We replace the selection with the component, and now we have a very simple chair component. Now what I'm going to do, I will make a few copies of this. I click Ctrl so that I'm copying. Then I take a point and I copy again. And let's just make this as an example. So now that we have our components, we're going to be inside the component and go to the 3D warehouse. And here we can search for the models we want to replace the chair with. So in this case, we're going to look for a school chair. And we have many options available. I like this one that is quite simple and looks like a real school chair. And we can answer yes when it's asking to load this directly into the SketchUp model. Otherwise, it will be saved as a separate file. Now that we do this, we have the chair here available, and we can just place it inside our component. And we can see that all the other chairs are automatically updated where other components were placed. So now we just need to move it a little bit further so that it matches the existing chair. And what we should do is to select the older surfaces that were here and delete them. So in this case, I only made 3 components for this chair. And if I had replaced already all the chairs with components, then all the chairs would have been changed automatically. Another interesting feature of SketchUp is the possibility to import materials and add them to your database. So as we use the 3D warehouse to import a component, we can use it to search for materials. So if we look for metal and then use the tag materials, we can find much greater selection than what you have with your original version of SketchUp. There are very interesting textures. If we import it, we just click download. And then we can select a surface and paint with the paint bucket. Of course, the material needs to be painted on both sides. Otherwise, when you export the GLP file, you might have problems in the visualization. So you reverse the faces and you paint again. This material is not just what you see, but it can be slightly colored. So if we look at, if we click on the one of these two squares here, where the texture is showing up, we can make another version of the material. So we can add the material here in the material tag, or we can make a new copy with a different color. So if I want a material that looks a little bit more green or more red, or even change the texture, we can do all our edits and save it as another material and apply it to the model. In this case, the original one was good enough. If we want to export the model for visual purposes, these windows that you see here that have a blue color, they will not be visualized properly because they have two different materials assigned. So first we need to apply the same layer. And more importantly, if you want the shadows to pass through the windows, what I recommend doing is to take the whole window layer and just hide it when you are exporting the model. Next, I will show you how to export the GLB file from a more detailed model. Now I will show you a very different model, a model that represents our previous office on the 5th floor. And as you can see, it is rich of details. You have the geometries that are rounded, they have textures, the textures represent materials where the light is scattered differently, the curtains are rounded, and so on. Before, it was not possible to see this model on top of the acoustic simulations, but now you can export this model as a very compact file format and just import it and overlay it on top of your Auralizations. Here we can look at all the details that this model has. It has some objects like plants, furniture that has a very specific designer. The windows have a lot of details, and all this will be kept in the model that you want to export. In order to do so, we go to File in SketchUp. If you have the Pro version, you will also see Export, 3D Model, and a series of file extensions. Among these, you should be able to see GLTF binary file, which is the file extension you need to import a file into the visual Treble Auralizer. So here we just give a name and the model will be exported with this name. I'm not going to start this because it might take a while to export all the textures in this model, but I have already some exports pre-made. Here we are in Treble and we can see the acoustic model of the same office we have seen previously in SketchUp. This acoustic model has very simplified features, but it's the same geometry, and it is also placed in the same origin. What we can do now, we're going to launch the Auralizer, and you can see that immediately I have the render model linked to this simulation. What you can do if you don't have this already linked is you just add the simulation, and then we pick a simulation that doesn't have the model already linked. For example, this one. Here you have a small icon that will appear saying Upload Render Model. So you will be able to just browse among your exported GLB files. So in this case, I'm going to upload the office without the dividers. In order to do this versioning of the model, you have to export the model first without the dividers and then without the dividers from SketchUp. So once this icon is spinning like this, you should be able to just close this window and keep doing what you were doing before. So now we can have a look at the model that I have previously uploaded. The model has all the features that you have seen in the previous SketchUp window. So all the materials we have assigned, the plants. Let's see if we can just pick at it from here. The materials assigned to the guitars, the textures assigned to the books, and this is also a way to maintain the work that has been put into assigning nice graphics to a model. You can, of course, navigate using the receiver's positions that you have previously assigned, And now we're going to take a look at the options where you can control a bit more the graphics of the render model. If you want to do so, you click on the icon, Render Model Settings, and a panel opens up with the details of the model. So you can upload a new model if you want, or you can delete the model. It is important to know that every simulation can be matched right now only with one model. So the model will be assigned to the simulation. Here you have a toggle saying manual alignment, which allows you to move the acoustic model, move the render model on top of the acoustic model if you need to do so. So in this case, they were actually matching very well, as you can see, because they were both placed with the origin at the right place. If you don't have access to the editing of the original visual model, then you can use this feature to align the two models. Next, we can remove the wireframe by closing the panel and open it again, and have a look at the environment features. If we look at the sky outside, we see that there are some clouds. And if we change the sky, there are different clouds. This difference in the background is not just a difference in texture, but is also a difference in the lighting inside the model. So if we remove the background, you will still be able to see the different lighting by cycling to the available options. As you can see, Sunset City has a warmer tone, Starry Night is a bit colder and dark, like a dusk, and Forest has more of a kind of countryside vibe that you can enhance by looking at some greenery outside. What is important is to use settings that you can preserve across the models that you're going to match with the simulations. So in this case, let's go back to blue sky maybe. And let's adjust the brightness and the light intensity. And we are like 56 as brightness. And we can also control the light direction. If we go to another spot, we can see that there is some light that is coming from the window, and this is possible thanks to this toggle called shadow casting. If we remove the toggle, the light will not be projected inside according to the openings in the windows. As I was explaining before, this is possible if you hide the actual surface that is in the windows, because if you leave the window on, the light will be much more diffuse. Still a really nice effect. So you can control the light direction using this controller with an arch, and you can control the light kind of orientation where it's coming from with this other cube controller. You can also, of course, use the input numbers to make sure that this is matching some other previous assignment for the model. And this is it for the settings. Now we can have a look at the two models. So if we click at the first simulation and the second simulation, we can see that this model seems not to have the shadows. So let's have a look and see if this is being set. We can see that this hasn't been set in the panel, so we just apply it. And we assign the same numbers that we have assigned before. And now the two models are matching. If we go to another receiver position in the model, we can see that this model has no dividers, while this other one has the dividers. And in this way, you can compare the simulations that you have previously run, showing to the customer the differences in the geometry features that are present both in the acoustic model and in the visual model. Now that we have created an Auralization with a comparison between two scenes, we can also share it with our customers or our colleagues. First, we want to save the preset. For example, we say Office webinar 5th floor. to make sure we don't have other simulations with the same name. And then we click on share, and we type the email of the person we want to assign it to, or we generate a link that can be just copied and pasted in the browser, like as simple as this. So right now I want to show you another model that is also representing a very nice geometry. This is a church that has been scanned with a LiDAR scan, and you can now import also LiDAR scans exported as a GLB format and overlay them on top of your acoustic simulations. And if you were making some surveys and you have a scan made from a phone and you have access to this kind of data, it is very interesting to have this possibility to make an acoustic simulation and overlay on top of that the scan. So we just click on the Auralizer. This is a very simple model I made just for demonstration purposes. It's kind of the empty void of the church. It's not supposed to be a real acoustic simulation. And we can see now that the icon is spinning and it's loading the model that I have attached to this simulation. So once the simulation is loaded, it will show up as rendered here. So we click on rendered, and here we can see the outside of this church. So this is the projection of the inside to the outside. So if we just look at the interiors, this is how it looks like. It's a very characteristic Norwegian church. And right now you will be able to create Auralizations and share them, and share together with them also the visual scene that is kind of made for that perspectives. So let's have a look at how you could do this. For example, we want to put some choir, load, and then if we want to share this, generate a link, we copy the link, and the church will be shown in the Auralization preset. So here you can see how I have the visuals of my church and I have access to the Auralization. So now I will show you how the model looks like in the shared Auralization window. I've prepared some sources for the soundscape scene of the office that you have seen earlier. We can see how the chairs, the armchairs look very defined, the leather sofa. Let's have a look at the back of the scene, the guitars and the light, the plants and the sky.
Yep.
So now we can take a look at the different receiver positions and start our Auralization.
Það koma á þennan viðburð. Já, akkurat. Ég sá ekki að það var eitthvað bannast. Já, akkurat áfangi, já. Er lagi að ég geymi nestisbox?
As I was showing you earlier, it is possible to compare the two graphic conditions of the model, and this will be reflected also in the simulations that you are comparing. You can also switch between the acoustic model and the render model if you wish to do so.
Paradis pour les amoureux de la faune. Vous pourrez observer des macaques, des renards arctiques et même des baleines.
Já, sko, við ætlum að skjóta auglýsingu sem að mun örugglega kosta samtals 20 milljónir. Þetta er alveg með nóg pening.
So this is the end of our presentation for today. We hope you enjoyed the new feature in the Auralizer.
Thank you, Alessia. I hope you found the presentation and the feature as exciting as we do, and we're excited to have you explore it and look forward to all of your feedback on it. But now I will give it over to Acentech, Jonah and Kalila and their presentation, after which we will have a live Q&A session with both me, Alessia, and Acentech.
Hello. Good morning from Cambridge, Massachusetts, USA. Afternoon or whatever time it is, wherever you are in the world. It's our pleasure to contribute to this webinar with Treble. And we're going to talk about two case studies. These are consulting projects in our architectural acoustics consulting business that use Treble. I'm Jonah Sachs, and I'm the Director of Architectural Acoustics at Acentech.
Hi, I'm Kalila Zaman, and I'm a Senior Consultant in the Architectural Acoustics Group.
Just a little bit about us. Acentech is an 80-person US-based consulting firm. We're headquartered here in Cambridge, that's Boston really, Massachusetts, and we have offices also in Philadelphia, Washington, D.C., Los Angeles. We provide a range of services, including architectural acoustics, noise control, of course, for buildings, building dynamics and vibration, and a range of technology services, and environmental noise as well. Okay, we're going to talk about two projects of ours in which we use Treble. Treble was very helpful. The first case study is at the Warner Theater in Erie, Pennsylvania. And the overall project was a light touch renovation of an early 20th century civic multi-purpose theater, beautiful Art Deco space. Rebuilt the stage house, major upgrade really functionally, but architecturally stayed more or less as is. And then there was a large addition on the upstage side to provide new support space that they never had, including a rehearsal hall. That's what the focus of this is going to be, the rehearsal hall. It's a beautiful rehearsal hall. It's oversized for orchestra rehearsal, as you can see from the layout here. That's because they use it also for events, receptions, gala, fundraising. You can rent it for your wedding, etc. The major acoustic design features in this room are the operable curtain, which you can see at one of the long walls. It more or less covers the whole wall. And then the wood slat ceiling, which is a prominent architectural feature, and it does a number of things acoustically for us. And that's really the subject of this study. Here's a detailed view of the ceiling system. It's a section cut through. You can see that there are the wood slats that you see, but then spaces behind the wood slats is absorption at the roof deck, and then plywood panels that provide sound reflection. So this is, acoustically speaking, it's a hybrid surface. It's reflecting sound with the plywood and also absorbing sound with the fiberglass. And the slats are, we think, mostly acoustically transparent. It's quite open. This is a ceiling plan showing where the reflectors are, because you don't see them when you're in the room. So you can see it's basically an adaptation of our standard rehearsal room approach, which is to put a mix of reflection and absorptive in the center of the room and absorption around the edges. Well, during construction, we learned that the ceiling construction was going to deviate slightly from design. And that deviation was that the plywood panels were going to be placed farther away from the slats than we expected. We accepted that, thinking it would probably be okay, but marked it for study later. So that's really what this is about. So when the room was done, Kalila and I went and attended a rehearsal and made some measurements. The most important outcome of that, of course, was that the orchestra is very happy. They sound good. We could hear the sections across the room well and clearly, and the orchestra is happy. The conductor is happy. The operations people were happy. That's the most important thing. But of course, as professional acoustics people, we wanted to know more technically how the room is performing, and in particular, what's the ceiling doing for us? So we measured a bunch of impulse responses between various sections of the room, and then later we studied it in 3 different ways. So this has kind of occurred after the conclusion of the project for our own learning. So we made an updated spreadsheet calculation, of course. We made a model in Treble, and then we made a mock-up of a section of the ceiling. So this is some decay times out from analysis of the impulse responses, just your usual EDT, T20 and 30, for various different conditions. Curtains extended, retracted, different positions. Then we built a SketchUp model, room geometry, surfaces, some beautiful, quite detailed SketchUp model built by a very talented summer intern that we had in 2024, actually. Brought it into Treble, applied absorption coefficients to surfaces. That was an iterative process. You take a first pass, you calculate, you compare it to the measured data, and then go back and make fine adjustments. In the end, we got it quite close to the reverberation times that we measured. What we're seeing right now is with the curtains extended between the viola section and the first violin section, and you can see that it has the frequency spectrum of the reverberation times is very rich in the mids and high mid frequency range, 500 to 2000-ish. Well, that's not too surprising given that it's different than a performance space. It doesn't have a lot of fixed furniture with a lot of high frequency absorption that we often see. We also, though, have some reflection from the ceiling. So we'll dig into that a little more. Okay, so then we made a physical mock-up of this ceiling slat system. What we see on the left is a diagram showing the slats, the absorption behind them, that's in pink, and then the plywood reflector in brown, and then measured the reflectivity of that system up close with an intensity probe called the microflone. Very cool tool, very useful, and found, perhaps not surprisingly, and as intended, that this system, even with the reflectors, is quite absorptive, especially at lower frequencies and up into the mid-range, and then becomes reflective in the 1000 to up to 2500-ish range, which again is as intended and matches what we saw in the frequency spectrum of the reverberation times. Okay, so our conclusions: the rehearsal hall performs as intended, highly intelligible across the ensemble, good blend, nice reverberation. The hybrid ceiling works as we intended it. It's mostly absorptive, but it contributes intelligibility cues in that important 1000 to 2500 kilohertz hertz range. And the Treble model helped us really to translate between the measured room decay times that we got from visiting the room and our up-close mock-up measurements, helped bring those together and helped us understand better what the ceiling is doing. So it's very useful.
All right, case study 2 is about the Mansfield Elementary School Dining Hall. And this project is a really, really beautiful space. It's very has a very tall ceiling, kind of grand for elementary school students. And the real issue with the space was that it was much too reverberant and too loud. These students in the photo look fairly calm, but in reality, they were not. And as you can see from some of the measurements that we took, their average sound level in this space was a whopping 79 dBA and a maximum sound level of 88 dBA. And you can even see some Lombard effect as the students quieted down to hear an announcement. And then the announcement was over, and then they were back up at levels that were even higher than previously as the sound built up on itself. The average sound level that we measured, if you look across the frequency bands, is highest at the 1000 hertz band, which we can see also corresponds to what we measured the reverberation time in the space at. Is the 1000 hertz frequency band had the highest reverberation time as well. So basically, the characteristics of the room and the reverberation of the room is also correlated with where the sound levels are the highest. And so as we worked with the school to set some acoustical goals for the project, we looked at several precedents of dining halls of varying scales and ceiling heights, as you can see from these photos, and compiled their reverberation times in this chart, which are kind of all over the place. But then we also looked at the average absorption coefficient of each of these rooms, which we found to correlate a lot more with how successful the space was. And the average absorption coefficient is basically like how much are the room surfaces absorbing the sound versus reflecting the sound back. So if you have a room that's totally absorptive, it would have an average absorption coefficient of 1. And if it were totally reflective, it would have 1 of 0. And so we found that the most successful spaces had an average absorption coefficient between 0.25 and 0.3, which is what we set our design goal as for this project. And we also set some RT goals. And really, the main subjective goals were to reduce the noisiness in the space so that both students can feel more comfortable and not have to shout to talk to their neighbor, and also to increase the workplace wellness for all of the staff that have to work in there. And as like a secondary goal, we were going to use the treatments that we proposed to try to reduce the apparent scale of the space so that it feels more like a space for elementary school students. So we used Treble a lot for this project to model all of our different options that we were going to present to the client. And, first started out with building our SketchUp model and then calibrating that model to our measurements of the existing space, and then building off of that to model all of the different treatment options that we were proposing. So we proposed to them a range of different options that really focused on giving them listening comparisons and also the visual corollary to these options of a or with an average absorption coefficient of 0.25 and 0.3. And we also had them listen to the existing space model to compare. So the first option was to have vertically hanging baffles, which could create like a false ceiling lower down and to reduce the scale of the space. Then we also showed them an option with these vertical hanging banners to try to get more light to filter through. Then catenary banners, so banners tight to the wood deck. And then an option that was more expensive, but still kept the wood look language that they had before. So what was really amazing about this project was, the culmination was that, we sat down with several stakeholders on the client side in the client space and set up a multi-headphone amp and presented all of these options using impulse responses that we took out of our Treble models, and then convolved with some other anechoic audio that we had to rebuild the scenario of a busy lunchtime. And with the existing space as a comparison to average absorption coefficients of 0.25 and 0.3. And right away, the clients, the stakeholders were able to say that they wanted to go with the average absorption coefficient of 0.3. And then what we got to talk about for the rest of the meeting was how it would look and how it would be constructed, how to make it actually happen. And so as we see here, we had 5 talking sources, 4 groups close talker, really helped them to understand how it would sound later on. And now, because they made this decision so quickly, they've already gone through a design phase, and they're going to be installed hopefully next summer. And this is what they're going to look like. And it's very exciting. And Treble made it happen. So.
Yeah, I mean, what's so exciting about this is how quickly the listening refocuses everybody on, okay, how do we make this happen? It communicates it so quickly and so clearly. And that's very exciting to us as consultants. Thank you.
Well, thank you, Jonah and Kalila, and also thank you, Alessia. So now it's time for the live Q&A part of the webinar. So feel free to ask your questions in the form below the video. We will be here for around 10 to 15 minutes, so all questions are welcome. Before we get into the questions, I think it might be interesting to hear a little bit more from Acentech. Jonah is here with us, about how they incorporate Auralizations in their workflow in general, since that has been kind of a focus of this webinar. Could you talk a little bit about that, Jonah?
Sure. Well, the example that Kalila talked about at the Mansfield Elementary School cafeteria shows that it's a good example because the way we see auralization in our practice is as a communication and group decision-making tool. So it allows us to communicate to our clients who are very often architects, but even more importantly to their clients, the owners of the project. Here's what we're trying to do. Here's a representation of the problem that you understand well. Or if it's a building that's not built yet, a new building, represent, here's what the problem would be if we weren't able to solve it in the way that we've recommended. And then here's what it sounds like with the recommendations that we've made, just to communicate the importance of it. Why are we recommending this at all? How important is it? And then we can also present different options. Sometimes, like in the case of the cafeteria Kalila talked about, there are many different ways architecturally to achieve the same acoustical goal. The acoustical goal in this case being put a lot of absorption up at the ceiling. But then we can present, well, you can do it this way, you can do it that way. Acoustically, it's all more or less the same. So it allows us to communicate the intent, the importance, and then also bring together the acoustical component with the visual component, so they can see what they're listening to, and use that to help reorient their thinking to practical design questions. And actually, I really appreciate what Alessio presented earlier, to make that easier to do within the Auralizer.
Yeah, we have certainly seen a trend from our users that Auralizations seem to be playing bigger and bigger role in the design process overall. Is that something you have felt also in your work?
Well, we've been using Auralization for over 20 years, and I would say that it's always been our goal to use it more often in our practice. It's still sort of a special occasions kind of tool. It's there for us when we have a situation where there is a really important design decision that probably has some cost attached to it, and it's sort of beyond the architect's ability to approve or to advocate for, because again, then we're in the position of talking about sound or dancing about sound sometimes, and that's a difficult way to communicate, and even more difficult for the architect to communicate for us. So it's so useful that way. Is it becoming more common? I believe it is. It's still sort of a special occasions tool for us, but we're hoping to change that, and we see these new treble features as hopefully presenting an opportunity to do that.
Yeah, that's certainly our goal with this, to make it kind of easier to set up and kind of more visually pleasing for these kind of, especially for these visually oriented architects and clients. With that, I think, thank you for the answer on this. I think I'll then just go into the questions. I'll try my best to answer them in order. So the first question I see here is about LiDAR scans. The question is, would you explain more about 3D scanning or laser scanning into Treble? So I think what I can say is that we'll have documentation on this, and you can always kind of contact our customer support as well. And on a very high level, the process can be done in when you have kind of taken a LiDAR scan using kind of a bespoke LiDAR scanner. You get out of that kind of a point cloud file, like a PLI file or something akin to that, and some pictures, which are then kind of given to you by the software. This you can take into a freeware tool like Blender, and then export it to this GLB format within Blender. So that, for example, the model that Alessia showed was done in this manner. I actually did the export myself. It took me about 3 minutes or so. It was quite easy to do, but I believe it can differ a bit between different LiDAR scanners exactly on the kind of finer details. So if you have something you want to set up, feel free to contact us with further instructions. Then there's a question here. Can I share the Auralization with my own WAV files and the visual model? And the short answer to that is yes. You will now be able to share with these kind of, you can create a custom visual model and upload custom wave files and share that to a third party, and they will be able to both see the visual model and hear the sounds you upload. Then a question for you, Jonah, is about here the microphone measurements. So the question being, can you speak a bit more about how the microphone measurement on the wood slat mockup were used with the Treble model?
First of all, hello, Tim. Thank you for the question. We love our measurement gadgets. I know you do too. The microflone is one of our newest ones. It's an intensity probe, but it's a new kind of intensity probe that is I think more usable than the older type. So how did we use it in this case? We used it to do an intensity scan of the mock-up, as you saw, and learn about its reflectivity. And then Treble really played the role of kind of unifier of different kinds of information. So the model, of course, was calibrated to measured data of the room acoustics, and then we had this mock-up information also. If we didn't have the mock-up information and only the Treble, we would still be left wondering exactly which components of the room features, which room surfaces were accounting for the acoustical performance. And we, of course, have our design intent and our educated guesses to guide us. The mock-up helped to confirm that, yes, indeed, it's the ceiling behavior that is responsible for the reverberation spectrum that we're seeing.
I can maybe add a more generic statement. I believe this device can also be used to measure impedance. Is that correct?
That's right, yes.
So in general, if you have such an impedance scanner, it plays quite nicely with the wave-based solver in Treble, since it's kind of fundamentally based on reflection coefficient, which is then directly related to impedance, and you can import these numbers directly into Treble for simulation purposes. So we encourage people, if they have such data, to just use it directly.
Ah, right, okay.
Then maybe one for you here, Alessia. Let me see if I can find it here. The question here is from Mr. Bridgman. What is the size limit of local audio files that we can share with clients in the Auralizer?
Mm-hmm. Yes, the current limit is about 30 megabytes. And of course, it will kind of depend. The length of the file depends on your sampling rate, the sampling rate of your WAV file. We haven't decided whether we need larger size yet or not. So feel free to comment. This was just what we decided in the kind of design stage, but we could certainly explore making the limit higher. And as Alessia mentioned, the sampling rate also plays a role. I believe it's 32 kilohertz. Isn't that correct? For the IRs, yes.
Yeah. So we're always open to kind of comments, but so it's 30 megabytes per file. So if you have a few different files, they can each be 30 megs. So here's another question. Is there a database with anechoic recordings within the Treble framework? Yes, there is. When you go into the Auralizer, you can access the sound library, and that is basically a database of anechoic sound that's built into the tool. And you can find the details on our documentation on how to access and set up an Auralization using just our own sound library. Let me see if there are more questions here. Here is a question whether the upcoming features that were mentioned will be coming this year. So I can give some insights into this. So as of today, you can upload the visual models and you can share Auralizations with your own wave files. Next week, we will have the lateral energy parameters. And then in a few weeks, we will have this kind of robustness increase that I mentioned, which will kind of enable you to create larger scenes in the Auralizer and share them with clients. So that'll be coming in October most likely. And the other features that I mentioned are indeed all planned for this year. And we have then much more on the kind of drawing board and in the early design stages that will, and some of them actually quite far ahead in design, that we will talk more about next year. Let me see here if there are more questions. Here is one question. Do you expect to allow for stereo wavefiles to be used so then can be assigned to stereo speaker setup? Can you address this, maybe, Alicia?
Right now you assign the sound per source. So we have imagined this as a mono WAV files to be assigned per source. We haven't designed a way to kind of assign stereo files to a source so that the source itself includes two different speakers. So the way in which the workflow is set now is that if you have two speakers, then you have to assign two different mono files. So you should split your sound in two parts if you want to do that, the two channels.
Yeah, I can also, this is a bit tangential, but I can mention that there is the ability that is kind of not available in the tool by default, but you can access upon request to get multi-channel output from the Auralizer. So as I say, it's a bit tangential to the question, but this is a possibility that not all of our users are aware of. The reason it's not available for everyone is because Windows has some kind of, can be difficult in this respect, so we recommend people to use Mac computers for this purpose. But if this is something that interests you, for example, if you have a bespoke listening room or something like that, you can contact us and we will give you further instructions. And then maybe here a final question. Will we be able to upload our own environment background images in the future? That certainly is something we could enable. We decided just to go with these few ones to begin with, and as I say, like if we get requests for it, then we will be glad to enable that feature. I think I have answered all of the questions, or we have. There's maybe here's a general comment from an anonymous viewer that they mentioned that for them Auralizations are becoming a standard procedure, so less specialized. So that kind of, I believe that fits in with kind of our perception of what's going on in the world of acoustics at large, certainly from what we hear and see. But with that, I think we can conclude this webinar. Thank you very much, Jonah and Kalila, for your lovely presentation and part in this Q&A.
Thank you, Ole.
And thank you, Alessia, as well. And be sure to tune in for more updates from us in the future. We have a lot of exciting stuff in store. Thank you very much.